question on that. Okay, so everybody is clear. So I can ask some questions, right? Okay, that will be a good idea. Can anyone tell me, like, if I have a two file in my local file system and I want to create a one single concatenated file in Hadoop file system, which command I will use?
I think it's to append.
Which one?
Append is
Append only? What you're saying? Append?
yeah, append.
There is no command append, first of all. Append to file, right? We are appending the two files, right? Okay, so we give the two files path and then we give the target path. Then we can concatenate two files. Okay, if I want to change the replication factor of my file in Hadoop file system, which command I will use? I want to change the replication factor. Because manually I want to change the replication factor by command. Because by default, the replication factor is configured in the configuration file. Okay. And now I want to change into
set rep.
set rep. What is complete command? Because set rep we cannot say, just set rep. What is a complete command? Yeah, you should be quick, right? Because Hadoop FS, we have to put it before the command Hadoop FS minus set rep and give the number, right? Which replication factor you want to set, and then after give the file path. That's it. Yeah.
Yeah.
See, command should be handy, right? Because if you just say set rep, right, who will understand, right? Right? What is set rep meaning, right? Okay, the complete whole command we have to tell. Okay. Suppose I have already one file in Hadoop file system. I want to overwrite that file. Okay. How can I do it? I have already one file. Okay. And I just want to overwrite again with the new content of my local file. So how can I do? How can I override the local content of the content of my Hadoop file system file from my local file? How can I override? How can I override the content? See, if these questions are coming in interviews, how will you face it? Okay, tell me, just like I'm asking questions like in interview, and these are basic questions like Hadoop FS minus put minus F, that will be overriding content, right? We already seen that, right? So this shows, right, practice is not there, right? Because installation is not enough, right? Because just installed and it will not work out, right? Without practice. Okay. So at least 2-3 times you do practice command, then only you can, like, you can speak to anyone, right? Anybody is asking. Suppose I want to change my original file, some number of characters. Like I say, I want to get only 3 characters. I want to change my complete original file. Can anyone tell what is a command for that? My original file I want to change. I want to change my original file with the number of characters. I say I want only first 2 or 3 or 5 or 10 characters. So how can I do that?
Set command is there.
Which command?
Set SED.
SU?
SED.
See here, this SAD or this command are not there in Hadoop command. I'm talking about Hadoop. That is, you are saying in the Unix file system. Okay.
Yeah.
Okay. I'm asking here Hadoop command are fixed command, right? If you do Hadoop FS, you will get complete list of command. Okay. So the command is a truncate command is there. Truncate. So truncate command you can do Hadoop FS minus truncate minus W. You give the number how many characters you want, and then you give the file path, and your original file will change. It will update your original file. Okay. Okay. So, but I'm just expecting, right, people, you guys should start learning and do practice. And what is the difference between the internal table and external table? Can anybody speak?
External table.
Internal table stores in the Hadoop warehouse by default, and external table it will get stored in the Hadoop, our local Hadoop.
Local Hadoop, there is no local Hadoop. Hadoop is only one, right?
We can give some like custom path for external tables in Hadoop file system other than the internal tables.
Okay.
And
I mean,
we
other-
use external command, external keyword
Hmm.
for external table.
But still, I'm not getting the main difference. This is just a one difference. Okay. One goes to the warehouse and one goes to the, okay, external location. If I give the
Okay.
location, even external
So
table can go also warehouse, right? I told, like, if I don't specify location,
For internal tables, if you delete
Hmm.
the table,
Hmm.
okay,
Yeah,
you
yeah, what
lose the
happened?
schema.
Okay. Hmm.
Okay, but for external tables, you delete the tables, the schema is still there.
Schema will be there and external table and data will be there.
Yes.
No, not clear. Okay, first tell me, if I drop internal table, what will happen? Schema will be deleted, or data will be deleted, or both will be deleted, or nothing will be deleted?
Both
If
will
you
be
delete
deleted.
it,
if you drop a table in it from internal table, the whole thing will be gone. If it's external, only schema will
It will
be
be
gone, but the data will be there.
Yes, yes.
That's
So
true.
we can recreate the table with the same schema. We can recreate table and reassociate with the existing data in case of external table. So data will remain at the same position. It will not gone. Okay. But in case of internal
Exactly.
table, your data and schema both will be deleted. Okay.
That's it.
Okay. Okay. Fine. Okay, let's start. I'm starting today partition. First, I give the brief overview of the partition because this is very important concept of the Hive. Okay, it's a heart of the concept. Okay, this is partition. Okay, so first we need to understand, right? We are doing the queries, right, in the Hive. Mostly we are doing select queries, but sometimes we do update and delete operations also in Hive. But those we need to set some configuration property, then it allows. Okay, but by default, the select operations we can do in the Hive. Okay, so whenever we are doing select operations, we know most of the times, like, we are getting the data, right? Some where clause we are using. So we know in the similar, like in the SQL databases, right? When we do city equal to Atlanta. So what it will do exactly, it will go each and every record and check the city. What is the city name? If it find the city is Atlanta, then it will pull the record. So if I say, if my one record is there in 100,000 record in my table, can you think of like how much time it will take? It will scan the whole table, right? Even though it's one record, it's a one record, but it has to check every record, each and every record, city, it has to check. So here, the one thing we need to pay attention, right? Like, how can we improve the performance of our query? So if I want to say, like, if I just make it separate out, my all cities data a separate logical group, my problem will be solved, right? If I say I have a 10 cities data, and even though my one city Atlanta has only one record, but the other cities have more data, and if I make it a separate group of these cities record, so when I say query city Atlanta, I will get the record within second. How it possible? Because this partition will logically distribute the data within table, so that when you say query, okay, and you ask, right, I want the city Atlanta, it will take the data from the partition. It will not go to check the entire scan of the data. Okay. So partition is a very great feature in the Hive that is making it more flexible, right? It is giving more performance, right? Improvement in the query, right? Most of the times when we are searching a data, and generally partition we use for the repeated data. Like suppose I say I have a different cities data, I have a different dates data, right? Today date data, yesterday date data, or I have countries data. Wherever the data is repeated, we use that column is the partition column. So any table, we have one partition column. So we have to decide how to decide the partition column. The partition column we will not choose for one record column, because if I say, if I'm choosing employee ID as a partition column, what will happen? If employee ID, if I'm choosing as a partition column, so if I'm choosing employee ID as a partition column, what will happen? So suppose if I 100,000 records are there, so how many partition will be formed? 100,000 records will be partitions will be formed. So that is not a good idea. Okay. So employee ID we cannot choose for the partition. We will use employee ID for bucketing. The next concept will come within partition bucketing, I will tell. But first we understand partition. So partition column, we decide the data which is repeated, and mostly we are doing the frequently queries, right? Suppose city column is there. I want to find the revenues of the, or I want to find the employees locations, right? I want to track how many employees from the particular city, count of the employees. So I want to use the city column or country column or dates, right? Like I want to load the data for a specific date, or I want to find date wise my revenues, right? I want to calculate like group by aggregation queries, right? Okay, on the date, right? So these all columns are partition columns. Okay. So employee ID, we can't choose. Okay. Because it is unique column. It is a unique column, and it will form those many number of times the records are there, those many number of time. Okay. Partition. Okay. So that is a bad design. Okay. So we will choose like city, country, repeated values data. Okay. Like gender. Okay. And I say dates, right? Like date of joining or date of birth, right? So many criterias are there. Okay. So once we define the partition, so we will choose the partition column on the repeated partition column on repeated value. Okay. So first you understand the definition of partitioning. So partitioning is in Hive is logically distribute the data based on the repeated column value. And when we are querying the partition column, we will get the result directly from the partition, not from the scanning the entire table. Okay. So partitioning is making
Is it the same concept as a group by?
See, group by is generally we use for the aggregation purpose. Here we are not doing any grouping. Okay. Just we are providing a logical like separation, just separation. Nothing we are doing any aggregation. This is the first step of grouping, you can say. Okay. Because if you are not doing partitioning, you cannot do the grouping, right? Grouping is partitioning, but grouping is further more action is there to apply some aggregation function, right? Group by is not complete without aggregation, that you know, right? Whenever you do group by, we do the count, average, sum, mean, max, like we apply some aggregation function, right? Okay. But here partitioning is not, it's equal to group by, but here we are not applying any aggregation function. Just we are making a separation, logical separation. Okay. Logical separation, just because of we want to get data retrieval faster. That's the purpose. Okay. So we cannot say it's the same as a grouping. Grouping is also one clause, right? Group by is there. Okay. But group by, when we start, it means we are going for the aggregation, right? Some average, min, max, I'm going to do. This is just for, it is simple select query, where clause is there. Okay. But internally it is handling the data performance. It is handling how to retrieval of data faster internally, right? But nothing is doing as a on the table. Nothing is doing on the table. Okay. Just making
Arvind, sorry, question. So when we create, for example, like hundreds of partitions, does that change how the data is stored in those the physical locations of the data?
No, it's just in the same table, within table, it's grouping. Well, it's a partitioning, right? Okay, if I say I have a room, right? So room is partition only, na? Otherwise, if I make it one complete like one room, right? So we can have any partition. But if I divide the room and then I can make it, okay, this particular part is used for this partition, this particular for this partition. So it will be easy. It is just for retrieval is easy, nothing else, right? If I
Yes,
say
okay.
something you are finding at a one place, all things together, or if I divide into the partition, which will be faster. In the
Okay,
practical
so the
example,
question is, so the question I'm asking is, how is that division happens? Like, is it kind of just put some walls between different sections of the room?
it's all internal. I'm still saying it's all internal, and partition is a logical. That's the reason they already given the definition. Partition is a logical division group, and it is internally maintained because when we create table command, it will do that. If you don't do create table with partition by clause, your partition table will not. It is not on the original table. It's not a normal simple table. You cannot have partition. Partition table is there. So you have to create from the source table to one partition table and load data from your source table to partition table. Automatically the logical division will happen. Okay, it will not happen without anything doing. Okay. So, but it is all internal things, how it is maintained, those partitions, right? But it is simply, it is maintain a same table data. Okay, just separation is there. So whenever you are asking, okay, I want city Atlanta, it will go to the partition, get the data. You will see how much faster you will realize it when the data size is really huge, right? Then you will see the performance. If I'm showing you just 2-3 record, you will not find any difference. But I'm saying if one record you are going to find, okay, and out of 100,000 record, okay, and only one partition record and one record, so you can see the performance. Okay.
Yep. Yeah. I've done partitions like using date string field for the dates. Like for example, daily data comes in. Every new daily data goes to different partitions. So I was just trying to understand the back end, like how does it work? Like, is it kind of just put in different? I know logical, like in even SQL Server, there is the logical, separation. But I wasn't sure, like if even in the disk, if it separates the data into different chunks in different locations, or if it's just one
Just some
table. But
internal mechanism will be there. Okay, even I haven't checked it. Okay, because mostly people, sometimes somebody ask how internally done. So that will be definitely some internal mechanism will be there. But without creating table, without creating partition table, it will not happen. That for sure, right? Because they have already given the partition by clause, and this partition table column should not be the actual column part of the column. That's the reason they kept it that column separate. Okay, so when you are creating table, we generally say the partition column will be separately given and other columns will be there in the create table syntax will give. Okay.
Yep. Okay.
Okay, so so first thing is we understood, right? Okay, why the partitioning is the purpose of the partitioning. The partitioning is basically giving the faster retrieval of the data as a logical division. Okay, and bucketing is another hand is a physical output file within partition, right? So if I say I have a data, logical data, but it's a single file. Okay, but again, if I want to search a one particular employee ID, I have to search all the record in the same partition, right? So what they're giving, you distribute the partition data into number of files as like using hashing technique, and that is called bucket. So each number of record, right, your file, right, that is called one bucket. Okay. So I will come to that bucket, right? So bucketing is a further enhancement in the partition when you are retrieving data within partition, right? So that will be making it more improvement in the performance when you are going to the bucketing. Okay. And even bucketing is also possible without partition. Sometimes if you don't want to do partitioning, you can directly apply the bucketing. Okay. So bucketing is an independent concept. Okay. Okay. So when I want to create a partition, like I have a table and I'm saying I have these three columns are there: employee ID, employee name, and salary. And the city column, I kept it as my partition column, and bucketed column is the employee ID. So clustered by employee ID into 4 buckets. Okay. So there is also calculation how to decide the number of buckets, right? So based on the data size, so there is a number of blocks, right? So we can decide. I will give that calculation also. How can we decide the efficient number of buckets. So any number of buckets you can give, your data will be distributed, your partition data will be distributed into the equal number of buckets. Okay, suppose total 100 records you have in a partition, and 4 buckets means 25 records will be distributed. And this will be based on the hash key. Okay, so employee, why choose we have employee ID here? Because employee ID is a unique key column. We have to choose for bucketing column, yeah, unique key, and partition column we have to choose repeated value. Okay, so that's a rule for the bucketing and partitioning. Okay, partitioning
One question is there.
Mm.
Does bucketing, I forgot the concept, does bucketing means data will be stored in ascending order or descending order?
It's not
Something
related to
like-
ascending, that is a sorting. Okay, which you are talking about, that is
That's,
sorting.
yeah,
And
correct.
we have the sort by. So sort by is a 2-level sort is there. One is a global sort, one is a reducer level sort, right? So global sort is a order by clause is there. Okay, and the reducer level sort means suppose you have a 10 files and every files having its own sorting order. Suppose I say I got a city Atlanta data and I want to do the sorting on employee ID, like 1, 2, 3, 4, 5 employee IDs. So that sorting is called sort by clause. So 2 clauses there. One is order by clause, one is a sort by clause. The sort by clause is working at the reducer level, output file level, and the order by clause is the global level. So order by is not faster because it's a global level, and sort by is faster because it's a reducer level. Okay, so that clause will come later. Actually, there are the total 4 clauses are there. One is partition by, one is a bucketing by, this bucketed by, this if you can see clustered by is the same like clustered by, which is creating a bucketing, and one more is a sort by, and one more is the order by. Okay, so we need to understand what all these 4 and where to use these 4. Okay, so partition by and clustered by is mostly is the same, associated each other. Okay, because generally when we say partition and within partition we go to the next level is a bucketing. Okay, but sort by, further you want to apply another clause, you can choose either order by or sort by. Okay, but when we are doing partition and clustered by, then definitely we go for sort by because we have bucketing. So bucketing when is there, then definitely you should go the sort by because you need your bucketing, you need sorted by sort by clause, not order by. Okay, order by generally normal table is there, right? Okay, I say without partitioning table, I will go order by. So order by is a global sort that is not having any sorting at the reducer, right? Okay, generally sorting the reducers come in the picture when we are having some group by aggregations, or we are doing some joins or something, like we are doing some reducer side, we are creating a multiple file, right? Then reducer comes in picture. Okay, or when we are going to create a bucketing, right? Okay.
I have a question here.
Hmm.
In your create table, okay, you have employer ID, employee name, but when you come to partition by city, city is not part of the table, or is it? Are you defining the city as a table at this point?
Which table you are saying?
I was thinking, I was thinking you define the city inside the table, and you partition by that field per se. Isn't it?
Okay, partition by is on city, and clustered by I'm using employee ID for bucketing.
I understand. But if you look at it, the EMP within bracket, I don't see city here.
CD, which city? City.
I don't see the city.
So city,
Yes.
I told, right, whenever this is a logical column, it's not required, right? Because the table is
Oh,
understood, the
okay.
total columns 4 only. But when I'm inserting
Yeah.
the data in the partition, there are the 2 ways. I will come to that, right? How to load the data, right? So when I'm saying city, I'm loading data. So there are the 2 ways. Either I can load the data by files, or I can load the data from table to table. Okay. So in this table, 2 ways we can load the data. So if I have a separate city data, I have a 1 city, X city, by city, G city. So I'm loading the city data, so I know which city I'm loading. I know, right? So I don't need to keep it the city column separately in the table column field. No need to keep it. Second way, when I have some source table and already table has the city column, right? Different city columns are there, correct? And these
Right.
city columns,
Right.
I'm using insert into table, and I will use a where clause from the source table. So which city I want to load in which partition, I will mention that. Okay. I will show complete static and dynamic partition. Then you will clear this concept. Okay.
Okay.
Okay. So first we understand what is static and dynamic. Okay. Static is manual partition when you are loading data manually in the partition table. Okay. So what it means? Suppose I have a different countries file is there. Suppose I got the data in the file. Suppose somebody told me this is X city, this is Y city, this is G city, and load the data into partition table. So that type of partitioning called static partitioning. Why it is called manual or static? Because it is manually we are loading data. And this kind of loading data, we cannot predict like how many partitions are there. Suppose I say 100 partitions are there. How many times you have to load data? 100 files you have to load. Okay, so they have given a solution for that. That is a dynamic partition. So sometimes, but dynamic partition works only for table to table. Okay, what is table to table? Like you have some source table, and in the source table you have 100 cities data. Okay, I want this 100 cities data with single insert command. Can it work in the static? It is not working in the static, because static means every time insert into you have to do 100 times. But dynamic partition is an automatic partition. It will detect the partitions and load the data into target partition table. Okay, just you have to run one single command. You will see one single command will load 100 partitions. I will show with example of 2 or 3 partitions because I cannot create 100 partitions, but example will work. If you work, for example, 1,000 partition or 10,000 partition or 50,000 partitions, it will work. Because if something can work for 1 partition, 2 partition, 3 partitions, so definitely it will work for 100,000 also. Correct? So the idea is, the dynamic partition is like we want to do the partitioning dynamically. We don't need to do one by one. But why still they keep it static? Because if they have already given an advanced concept dynamic partition, why they keep it static? Okay, so dynamic partition is not a default partition. It's not we need to configure property for the dynamic partition, then it will be allowed. And second thing is, static partition is used for when you have 1 or 2 partitions. Okay, like if a case a gender, so male and female 2 cases are there, or where I know only just specifically only very less number of partitions are there, I can go for static. So in static case, just you are loading data 1 or 2 or 3 times, that's it. But dynamic is like when you have 100, 200, 500, so you don't know how many partition can be formed, you can go directly dynamic partition. So dynamic partition will take care of that part. Okay. So first thing is clear, why static, why dynamic, why we not to choose static, why we choose dynamic, and why static is still there. So these are all questions are there. Okay. Now we will start our example first. So we will be doing partitioning practical, how this partitioning is working, how will, but static or dynamic, both are giving the same result. Okay, there is no difference in the result. The only difference is how fast you can do static to dynamic. Dynamic is very faster because dynamic is not depend on you. Dynamic will do automatically. Okay, but static is depend on you. You have to load the data in the table manually one by one. Okay, for the each partition. So all partitions are depend on you. But dynamic, the partitions are not depend on you. Just run one single command, it will do all partition together. Okay, so that's the advantage of the dynamic partition. Because this partitioning concept is very important to understand, because they want to know why partitioning we are going to do. If normally if I'm doing select star from table, so first thing you have to say, we are not doing the whole scan of the table. We are not doing, because we want to avoid the scanning the whole table. So we create a partition table, and partition table, like you can just get the data directly from the partition table because it's a logically group, partitions are divided. Okay. So the partitioning is important because partitioning is a not new concept. Actually, partitioning is everywhere. If you see in a Spark, the data is distributed into the partitions and parallelly processing the data, right? So partition concept will be coming everywhere. MapReduce also have partitioner. You already seen the hash partitioner. I given the example of the partitioner, right? You created a multiple output file. So partitioning is everywhere. But how the partitioning is implemented, the concept is different place, different way is implemented. But overall, the partitioning is the faster performance, right? Like we can improve our queries. Okay. Anybody has any question can ask me. Then I will start the practical example. Okay, so first I'm starting my Hadoop. Okay, start hyphen. So I will check it if my Hadoop is already running or not. Not running. Okay, start hyphen all dot sh. See, very simple step by step you will do partitioning, and I'm telling you step by step you will do, you will really understand well, and you can make someone understand how to do partitioning practically also. See, two things are there: theoretically someone to make understand, and practically make to someone understand. Theoretically you are making understand means just you are giving a definition, so this is very easy. Okay, but practically you are making someone understand. You want to tell the command like which command you are going to use: create table command, load data local command, then you are loading the data into partition wise, and then finally you are doing the select query. So 3 steps command you are telling, someone can understand, you know, practically partitioning. Okay. Okay, so now I'm starting my Hive. Okay. Already you guys know load data local in path, so I'm not going to explain that command because I already told about in the internal external table how to data is loading. So I will be doing the same command because whatever command you are using, load data local in path or put command, whatever way you want to write, you can write the data. Okay. So that concept is same entire in Hive. Okay. Loading data different way. Okay. Any one way is fine. Okay. So first we go to check our database, show databases. Okay. We will use testing database. Show tables. Okay, so there is no partition table. Okay, so first thing is we'll start. Okay, so here is the table name is student12 static. Okay, just I given the table. Okay, and this table has 3 fields and 1 partition column. 3 fields: student name, father name, and percentage, and partition column name is section, because I want to divide the student based on the section, right? So I can easily retrieve the data section wise. So I have created some sample data. One is the section A and one is the section B. So these are the 2 students in the section A and these are the 2 students in the section B. Okay. So it is well and understood, right? This is the first name. This is the name of the student. This is the father name and this is the marks percentage. Okay. Of the students. Okay. So first I'm going to create a table, and last time also I told like how to create a table. So create table here, and this table is a partition table. Okay. This table, why it is partition table? Because clearly it is mentioned partition by clause, and you are giving a choosing a column which has the repeated data. So section column is a partition column, and that is not part of your table columns. Okay, because it's a logical column. Okay, and row format delimited and fields terminated by comma. Why comma we are using here? Because my data in the file is separated by comma, because when I will load the data into Hive table, so it will be parsed from the comma delimited file. Okay, so I'm going to create a table first. So this is my first step. I'm going to create a table. Okay, I will verify the table, show tables. Okay, select. If I do, I will not have any data. Select from. Okay, so there is. Okay, I have given wrong. Student 1, 2. stat. Okay, STAT. Okay, so there is no data because so far just I created a one partition table. Okay, so now the next thing is I have to prepare the data. Okay, I have to prepare data. So I'm creating a file. Okay. I just keep it file name is section underscore. Okay. So I will take the data. This is my data. Even you can type it also. Control D. My one file is created. Second one is A1, B1. So one section is A1 section, one section is a B1 section. Okay. I will be creating a second file. This is the section B. Control D. Now my files are ready. Now I will use this command. I will use the command for loading the data. So I will be using the load data. So here is one thing. So this is my Hive test 3. Okay. Section underscore A1. This is Hive test 3. This is my input folder where my file is there. Section underscore B1. Okay. And this is my table. So I'm saying here, if you have seen the last command, load data local in path into table, till here you give the command, right? But in this command, you will see there is a partition clause is coming, and manually I'm saying section equal to A. So this is the column value for which the data is inserted for the file, for this particular A1 file. So here is the mapping. So you have to remember whenever you are giving section A, or you can make it any name. So if you do query with section A1, so A1 will be your values, right, for the section. Okay, here is the section is B1. That is up to you, whatever value you want to keep it. So section is A1 and my file is a A1. If my section is B1, my file is a section B1. So I am making sure whichever file is whatever file name, and that file is going to that particular partition. Otherwise, by mistake, right? Suppose you loaded section A here, A1 in the section B1, what will happen? Same data will be there. So you need to make sure, and once it is loaded, you have to drop the partition, then only you can remove the data. Okay. Otherwise, that's the reason we have to first see which partition and which file we are loading. So that's see, static partition, what are the disadvantages? These are the disadvantages. Like, because we are very, very careful, because dynamic partition, you don't need to take tension. You don't need to worry about that. Where the partition will go, where we, so this all things you don't need to take care there. But static partition, you are doing manually. Okay. So then you are doing this all things you are taking care. So simply, I will load the data. So first I will be loading data for partition, for section A partition. Okay. Semicolon. It will be running a MapReduce job. Loading data. Okay. This is directly loading. So see, loading data is very faster. Okay. You already know whether you do without partition or not partition, it doesn't matter. The data loading is faster. You already know I told about this because this is a schema on read, because it is not checking any validation while loading data. It will blindly it will write the data. Second one, I will copy the second one. Second one is my loading the data into second partition. Okay, so how many partition is created? How many partitions are created so far? If I check show partitions,
A1.
though one partition,
Because you have A1, section A1, section A1, both of them.
yeah, so two partition is student 1, 2. Can you see? You can see here also the number of partitions are coming 2, right? One is section
Yeah.
equal to A, one is a section equal to B. So if you see the
B1, yeah.
location, if you see the location, because these are the internal table, so definitely the data went to the warehouse directory because I have not used external keyword and I have not given any external location. So definitely the data gone to the warehouse. So Hadoop fs minus ls, then I say user Hive warehouse testing.db and then my table. The table will be a table folder, and here will be two partition folders will be created. So one for the section A and one for the section warehouse is spelling wrong. Warehouse. So you will be seeing actually some other already this table I have created number of times. So I should change the table name because previously I have created this table in December. Can you see here December? This is the, so this location, the data is already present. So those data will come also. Okay. But that time I loaded data with the different partition name, right? Section A, B, C. Okay. And this time I created A1, B1. So this is today date. You can see the date, right? So location is same. That's the reason Hive command is just putting the file, nothing else is doing. Load data local path command is just keeping it the file in the this partition folder location. Okay. And your data will be populated in the table. Now, if I do select start from onto underscore stat and where clause I gave section equal to A1. So single code I have to give A1. So two records are coming. This is coming partition. So you will not feel like it's too quick, right? But I'm saying when you have large number of data, it will be coming. Okay. So section B1, section A1. So this is static partition is done, right? We have done file to file, file to table. Okay. So we have created first table, partition table. We created data and then load the data into partition by load data local command. Okay. If you don't use that command, so directly you can Hadoop fs minus put and the partition location folder, this location, you keep it the file. So your data will come. So either way you can do. Okay. And once your partition data loaded, then you can do the query. Okay. So these are the steps for the static. Now we go to the static partition from table to table. So table to table here, whatever my these two files data, I will make it one single file. I will say I section A, section B, but in that table, I will keep it section column. Otherwise, how can I know if I keep it these four record in a one file, how can I know this record, these two record are for section A or this record of section B? So for that case, I have to create one section column also. So in this table, the source table, the section column should be there. Can you see here? The section column is a part of the table. Okay. Once this data, this part is not related to partition. It just you created a table and then you have this data and you loaded the data into your source table. So if I see till here, these three lines, these three is related to just normal table you have and you are loading data into source table. Next step, you are creating a same partition table. Actually, this is again source table. It's not needed. Okay, already source table we have here. Okay, so once I load the data into source table, I will create a partition table, same thing, whatever I was doing, and I will load the data by using the insert into command. Why I'm using insert into command? Because table to table data loading is done by insert into, not with the load data local file. Load data local file is a file loading, but insert into table command is a loading data from the table to table, like source table to target table. So source table is this is my source table, and here is my partition table. That is my partition table. Okay. So we have to do all these steps. First, I'm creating my, because this single quote now you can get the error. So make sure like you can change this single quote, then you create table. So I will be giving a source table some different name because otherwise it will be already some table will be there. So I will be creating a source table. Okay, my source table is created. I will create a one file. Let's see, I have a file here. So I have a sections.txt already here. Okay, any file I can see, get section.txt. So this file has the data, right? I'm not creating a data. I'm using this section.txt. So I will modify my command. I will modify my command, my Hive test3, my Hive test3. Okay, and my file name is section.txt. Okay, into table I have given this, just copy this and paste it here. Okay, and now this command is ready. You can copy paste. See, you should have the practice of writing command also, because copy paste will not give you confidence. Okay, you should try it out, because I have done many times. So I'm just copy pasting and showing to you so that I can show you faster. Now I have loaded data. This is a source table. So simply select start from, I will be doing student source 121. So I will be pasting here. So this is simple thing I done without partitioning, nothing related partition, just create a table, created data, and then loaded data into the source table. Now I have a 4 column, and here is my section column, because if I don't keep it this section column, I can't identify which records are A and which record is B, right? Section A, section B. So now I'm going to create a one partition table, because I can use the same partition table, but I don't want to mix it. So I'm keeping it the different name. Okay, so that my table will not mix. Okay, so I'm creating same partition, same command. It's nothing different, same this command. Okay. The only thing is I change the name, but I'm keeping it here partition by clause. Copy this command. Now the same process, whatever you did static, you will do the same, like you create a table. After that, you will be doing insert into table command. This command you need to understand how many number of partitions will be there. It is again manual. It is not also automatic. This is also static or manual, but only difference is you are loading one by one file. Here you are loading the data one by one. Okay, here you are using insert into command. There you are loading load data local file command. Okay, because maintaining the separate file, it's a big headache. If you are keeping the data in a one single table, that is easier, right? Rather than you keeping it separate file. So here, when I'm inserting data, so keep in mind, if you don't give, like here you are giving the partition clause, right? You are giving a specific partition name. So here the synchronization should be there. So we have to make sure, if I'm taking as a where clause section A data from the source table, I'm going to write the data into same partition column. Okay. So otherwise, if I just mismatch here, my data will be loaded not correctly. Okay, the data will be loaded, but it will be mismatched partitions. Okay, so you will not get the data correctly from the same partition. Okay, so insert into command. So insert into target table. What is my target table? This is my target table. I will change the name here. And partition clause will come here in the middle. Okay, so in the partition, after that, select clause. So you know, anytime we write insert into table, then select star from table. This is the command to read the data from source and write the data to the target. So here target is your static partition table, and partition clause you are giving in the middle to tell for which partition you are going to read the data from here and writing the data here in the target table. Okay, so now I'm running this command. Source table is different. My source table is a 1 to 1. Okay, 1 to 1. So whenever you are writing, just make sure like your command, your table, write with the proper name. Otherwise, you can come to know, right? Table not found means the table is not there. Okay. But you are creating first time. So for you, it's not a problem because you are following the instruction. you're following the steps, so you will not get a problem because the same command you are using, the same source table we are using in the our command done. So here is the map reduce job. So it is writing the data into partition. So first is loading data into the partition table. Second one is just we have to change here B, and here we have to change section B. Okay. Section B, section. So again, this is a second load data. So it is filtering the data from the source and writing the data to the target partition. Okay. If I don't give this where clause in the source, what will happen? In that case, what will happen? Suppose if I don't give this source where clause, what will happen? If I don't give this source where clause, what will happen? Can you tell me?
Copy on the data.
It may fail because you are specifying a section.
It will
section
fail.
A.
But why it will fail? It will not fail, right? Because see, here I am not giving partition clause and partition value I'm not giving. Okay, that could be a problem. But here I'm not giving it means it will take it all data. It will take it because you are not filtering. So all the data of the source table will go in one partition. Correct? So, and same thing you are doing here also. So what you will see, 4 records are total number of record 4. So every partition will have 4 same record. So there is not a correct, right? That is not correct, right? So that is the reason where clause is needed. Where clause is needed. Okay. And if you are load data command you are using, suppose here from the file, and you say you are not giving this partition clause, what will happen? If you are trying to load data, this data, you are trying to load data and you are not giving this partition clause. Okay, what will happen in this case? Suppose you are having loading the data from the file. Okay, everything is correct, but you are not specifying which partition you want to load. What Hive does? Hive will create a one default partition. Okay, it will automatically create a default partition. I will show that. It will create a default partition, and that partition will be something name is default underscore something partition. So it will create a default partition. Okay, so that is not.
Is there any reason,
Hmm.
is there any reason that this process is slow? The one you just ran.
Which process is slow?
The operation you just ran before.
It is not slow, right? It's just less data, right? See, depending on, see, yeah, this is the map reduce job is running. See, that one we did load data command. It is loading data dumping.
Yeah.
Okay. But table to table operation is a complete map reduce job, right? Because it's not simply dumping data, right? Because there, when you are loading data into table from the other table, it is validating, right? All these map reduce stages are there. Okay. So map reduce
But
stages are there.
even at that, we don't have much records here, and it's taking time. So what happens if you have hundreds
See,
of
I'm telling
data?
you, Hadoop, right? The thing is, if you doing 5 record, because the other things are also there, right? Metadata things, updating the things. So if you're less number of record, don't expect for the Hadoop is not for less record. Hadoop is for the large number of record. If you are trying less record and you are expecting more faster, it will not be possible because the metadata maintaining all those activities, it will take time. So for less record, we cannot expect that it should be too quick, very, very quick, right? It is not that much quick, okay? Because Hadoop is meant for because this data loading in Hive, we are not doing 1 to 1 to record, like just very few record. We are doing thousands record, millions record, okay, 100,000, right? These kind of data are coming every day. So in the real time, we will be expecting the big, large files, big, large table data, right? To load, right? Okay, this is just for practice purpose, like we are checking it. So here expectation, like if we keep it like, okay, if this 5 record or 3 record is taking 30 seconds, it should convert into just fractions of second. It is not possible, right? Because the other activities it has to do, right? Okay, and this is a map reduce job. So map reduce job is definitely different stages are there, right? Parsing the query, compiling the query, converting logical plan, physical plan, and then map reduce plan. Then finally map reduce job will run. Okay. And when you see load data local path, even 50,000 record within the 2 seconds will be loaded. Okay. So that's a different scenario. That is just keeping the file into the location. That's it. See, copying the file, how much time it takes? It is very quick, right? If I say I'm local file system, I'm copying put command. So load data local command also doing the same thing, right?
About Hive right now.
Who is paying? So load data local command is doing the same thing for us, right? Just copying the file. That is the reason it's faster. But this insert into table command is not like a local command. It's running a complete MapReduce job. Okay. So MapReduce job will take time because there are multiple. There are the multiple stages are there. Okay. So let's see the data here. Like select. So this one we did table to table. Okay. And our partition table is this. Okay. Section A data, same result. Result is nothing different because partitioning this file to file you are doing or file to table in static, both are nothing different in the result wise, nothing changed. Okay, just we are making it multiple files instead of loading multiple file. We created a table, but still we are writing two times insert into command, right? So that is still overhead. That is still overhead. Okay.
Yeah, if you don't put the where clause in the select statement, it will show the 4.
All 4, yeah, because that means like I'm not looking for partition data. I'm looking the entire data. So there is no role of partition because partition when come in picture when you are doing the where clause and give the column, then partition will do effect. Otherwise, this is the normal table query, right?
Right.
All partition will come. Okay. So now we go to the next is the dynamic partition. Okay. So let's see that dynamic partition. So it's very fast also, like, okay, you same steps we are doing. So source table we will not create because source table already there. We will use the same source table. Student source 1 to 1. This is my table, right? So I will not create the source table. I will create just dynamic table, dynamic partition table I'm creating. So this is my dynamic partition table. And this is also the same partition table. There is no syntax change, nothing. Okay. Only thing is your insert command will change. Now insert command, only one insert command. And this insert command is not taking any where clause here and no section value is here. Okay. So this is only difference in the insert command. Also difference is you remove the here section equal to A and where clause you remove. But one thing you have to remember.
What makes it dynamic?
What makes it dynamic? Okay.
Yeah.
Suppose this property, if I'm not using, it will fail because this property is making it dynamic. Okay. Otherwise, okay. If I show you that, what problem will come? If you don't use this property, what it will say? Okay. First, let me create dynamic partition table. Okay. So dynamic is nothing special in this table, right? This is the same table, but I'm keeping it different name. I want to make sure like my data is properly going in a different table, right? Otherwise data will be mixed up, right? So this is, I created a one dyna partition table. In this table, if I don't, okay, in this table, I should change the name here. Okay, because this is my target table and I'm just taking it the same source table. Okay, and I'm not setting this property. What will happen? Will it understand or not? Okay.
We will not understand.
What it's saying, dynamic partition strict mode required at least one static partition column. It is saying two things, either of the two things you do. Either you keep it your partition as a static, make it value as a static you give. If you are not able to give that, then make it dynamic partition non-strict mode. Non-strict mode means like you are not keeping any restriction. Okay, so turn this off, set property. So it is saying we have to set this property. So set command and just put it this property. Even if you don't keep it the other property, that is fine. If you don't keep it this property dynamic partition true, that is fine. But if you keep it, that is good because this property is needed when you are going to bucketing. Okay. So keep it this property also on, set property, dynamic partition true, and this this two set, and now I will run my existing command. So now my command will be dynamically loading data. Now it's working. Okay. And one more thing you have to remember, right? I forgot here. Like when you are loading data, so last time you seen the insert into command when you use this one, when you did the section A, section B. So here not keeping the section column, because section is you are viewing in the where clause. So you don't need to give here section column. But here the section column is mandatory. This one. And it should be the last column also. It should be a last column if you select. Otherwise, if you keep it in the middle or anywhere else, it will not recognize. So this is a contract. This is the contract. Whenever you are loading data into dynamic partition table, so section column you should give without value. And here the section column should be the part of your column field, and it should be last one. Okay. So it is just matching it. It's just matching it. This to this, it will match. Okay. And load the data dynamically into this dynamic partition. So now only one time I'm running this query. This insert query I'm running only one time. So it will load both the partition. Is it done? Right. Now I check my this table. Okay, select start from. Okay, if I okay, this is the all data. Same thing is coming. So dynamic is not meaning like dynamic will data bring faster than the static. It's not like that. Dynamic is just making the ease, right? Like it is making it more easier, like to write partition instead of writing separate insert command, you will be doing one single command. Okay, so that is the only advantage. Otherwise, nothing difference in the result. It's and nothing is faster. It's not faster or nothing. It's just writing data into table faster way, right? Rather than writing multiple. Like suppose if I have section 100 sections are there on these 100 sections data in my source table. So how many times you write the query in the static insert into table command? 100 times. So here is the advantage. Only one single query. So here dynamic partition is taking care of all the things. So you don't need to worry about how to write the data, what column, what partition, just it will automatically do. Okay. So this is the scenario for the static and dynamic. Okay. Okay, so anyone has any questions on this one, static or dynamic? Okay, it's clear.
Clear.
Okay, so next thing is a complex bucketing. We will take it. I'm taking it one complex data type. Okay, so complex data type is very important part of like Hive, right? Because generally Hive is supporting not only primitive data, it supports a complex type data. So how many types of data types are there? So first we understand how many types of data types are there. So there are two types of data type category, primitive and complex. Okay. So primitive is generally all tables are all databases like generally have, right? We have int value, string data type column, double is there, float is there, right? So these are primitive type. Okay, but what is the problem, right? Suppose my requirement comes, I want to save my student marks. So if five subject marks are there, how many columns you have to create? So student ID, and you say marks 1, marks 2, like subject wise you will create a, this is the one ideal way you will do. But if I say this all marks are the same type or not, these are same type, right? All are the integer type. Okay.
Yeah.
So this marks columns, marks all are the same type. Can I make it instead of separate column, I can make it one array of marks like this. Okay. So what it will do, it will maintain an array. In this scenario, any number of columns can come. Okay, marks 1, marks 2, or 100 marks, any number, right? Because I'm maintaining the array. Okay. So array, the advantage is I will maintain the index. So now question comes how to get the values of each this marks column. So there is a index value, right? It is start from 0, right? Marks of 0, marks of 1. Like this, I will access the each marks column value. Okay. So first of all, the primitive data type is not able to handle collection types of data. So somewhere I have a like a collection types of data, array is there, or I say another type is there, struct. Struct is array and struct. What is the difference? Array is for the same data type, but struct can take multiple data types. Okay. Suppose I give you one more example. I have student ID and address. So if you keep it, either you keep it this complete string as an address, entire address. So you will write address like this. Okay. Okay. Address I should not write because it's a violation for the YouTube. Okay. So here is student ID and address, you keep it. So address will be, you give a whole string. You give the whole string as the address. But suppose if I ask you city, what is the city in this address column? You will have to write some function and get the data, right? I make it more easy if I keep it student ID and I create a one struct type address column. I say struct address and I give the different data types, like say city, like I say house number is a number type. Okay, that is an integer. And next is I say street, that is a string type. Okay, I say like city. Yeah, please mute. So street is a string and city is a string. Okay. Okay. So city is a string. Okay. And this type of data I want to store. So is it make it more easier? Whenever I want to take it house number, I can access from the this address column. So my address is a column name. My struct column name is address. If I do address dot house number, what I will get? House number. If I say address dot city, I will get city. If I say address dot street, I will get street. But here, why I'm not making it array? Because array is the problem. Array can be on a same type, either be string or int or float or double. All values should be same type. But here is the flexibility. In the struct, I'm getting a flexibility. Okay, house number, you want to keep it integer. Street, you want to keep it a string. City, you want to keep it a string. Country, you can keep it a string. Zip code, you want to keep it as an integer. Okay. So this is in your hand, what you want to keep it. Okay. So you are defining the second complex data type is a struct. Third one is a map. So total 3 complex data types are there: map, array, and struct. So map is a use case when you have key and value. So suppose I say one map data type I want to define. I say my string is my key and value is also string type. So suppose I'm say some PF. So PF or PDF, some EPF, right? Some provident fund I say, and that is associated with the employee. So I say employee ID and amount. So I can keep it integer type and value I can to keep it as double type. Okay, amount. So this way I can define the map type. So the advantage of map is like I want to have a key and value. So I can get the key, I can give the key and get the value. Okay. Now let's see the practically. Okay. So here, so I already explained to you all this, like we are using complex data types for the collection types like array, struct, map. Okay. So first of all, we are going to create a some file and how our table will be there. See, if you are using your complex data type in your table, so definitely your data and table both should sync, right? Suppose I'm keeping it here. My ID is there 1, name is ABC, and salary is 40,000. But after that, I'm creating an array name sub, SUB. And this array is having the 3 field A, B, C, and these are separated by dollar. So the separation is very important because you are telling here, like your fields are separated by comma, but your collection items separated by dollar. So you are telling here, your collection items are terminated by dollar and the fields are terminated by comma. So this synchronization should be there in the file. Otherwise, it will not be able to parse. It will insert null. It will insert null. So if you want to insert the right data in the right column, so you have to give this mapping. So here is field terminated by comma. Why we don't keep it comma here? If you keep it comma here instead of dollar, how can you recognize this is an array? Right? This is an array collection. So we kept it. The collection items are separated by a different delimited character. You can use pipe symbol. So you can give here pipe symbol. You can use the hash symbol, pound symbol. You can give any symbol. Okay. But it should be different from your field terminated by delimited character. Okay. So first I'm going to create this file, array file. This is clear, like why we are going to use array. First of all, because we know that array is for collection, right? But what is the purpose is solving, right? Because we want to create any number of same type of data type columns which are associated to each other. So marks are related to all subjects. Marks are the associated with the student, right? So here I'm keeping it array column is a marks column. Okay. Okay, array file is not there. So I'm creating cat. Okay, Control D. So my array file is created. Now I'm going to create a table. So this table, this is already having this angle bracket. I have to remove it because this angle bracket is not needed. So row format delimited, field terminated by comma, and collection item terminated by dollar. Okay, so I'm going to create a table in the Hive. So load data process, we know, right? We have to do the load data. So that is the same command, load data, local in path, then single quote. I will give my path Hive test3 and slash. I will give array file. Array file is my file, and into table tab 7. So it's the same command. Okay, just we are loading data. Now we will do the select start from tab 7. So when I do this, I will get, so already the tab 7 table is there. Okay, so it is repeating data is there. Okay, so can you see here? I'm getting the all array values together because I'm doing select start from table. ID column is coming, name column is coming, salary column is coming, location column is coming, and array column is coming. But I say I want to get the specific column and specific index of the array. So I say my index name is sub. I say sub of 0, sub of 1, sub of 2. But some places you have only 2 values are there. So what will happen in that case? It will bring the null. So wherever the third value is not there, you are getting null. You are getting null. Because value is not there, definitely it cannot find anything. It will be returning you null, right? And now, once you have the data, this data is a array data. Okay. So suppose you say one student has not having any marks. So that will be null. And one student has 3 subject marks, A, B, C. But the one student has only 2 subject marks. So that this 2 subject marks will come. So this is array. How to use other 2 different also, map and struct. So only one simple example is there. In this example, all 3 are there. Can you see? How can you identify all 3 are there? The first one is A, B, C. So this is if you see the field name is sub, same thing, A, B, C, okay, D, F, okay. And second one is this, if you see after comma last one, this is the address. So ADDR, you have city, state, and pin code. So city, state, and pin code. Same thing is here, city, state, and pin code, right? And the one is in the middle, that is your map type. So map type you're defining string comma int. And what is the column name you are giving for this? DUD, deduction. So here the separation is there. Actually, you know, map type having key and value. So definitely the key will be separated by value. So hash symbol they are using for separation of the key, but the collection, because this map also have two items. One item is this and one item is this. So every item is separated by dollar only. That principle is same. That rule is same for all the type of collection. So whether it's a map type or struct type or array type, the collection item terminated by dollar, only one more extra come here, map key terminated by hash, only for map, because map has extra one more separation of key and value. How can I say this is my key and this is the value? The first one is key, second one is a value. First one is the key, second one is a value. But here is a only one key value. Here is a two key value pair is there. Okay. So multiple key value pair can be there, right? So their separation is there dollar. If one key value pair, then only key and value, the separation is hash. Okay. So I'm going to create this file. So you need to understand file. You need to understand the table and then create a table, create a file and load data. That's it. Okay. And then after you select query to get the data. Okay. So I'm creating this file. Cat. Just I'm giving any name. Cat greater than map file. And I'm writing data. Okay. Now I'm creating a table. So while you're creating a table, we have to remove this greater than sign symbol. So this symbol you have to remove. So I'm creating this table. In the Hive. Okay. Now the load data local command, same command, load data local in path. So what is my file name? What is my table name? My table name is 11. And my file name is map file. So it should be correct mapping, what table, what file. Okay. Once data loaded, now first we check the entire data. So let's start from tab 11. So I'm getting all the data. Okay. So here is the case, right? Because you are getting 2 times 1, 2, 2 times 1, 2, because this is mapping somewhere as the data is there. Okay. So data is okay. So if I query, if I say I want to get all individual field, I say ID, I want to get name, I want to get okay, I want to get the array column. Array column name is sub. So array column name is sub. You can see here array column name is sub, and DUD is a map column, and struct column is ADF. So this is very important, how to access all these different collection. Okay. So first array already we see. Everybody we know, right? We can give the index. Whatever number of columns, indexes, values you want to get, you will give those many. Suppose I want to access my address column values. Okay, like that is a struct. So a struct is like basically your column name is ADDR. Now you say city, ADDR dot state, and ADDR dot pin. Okay, so it is not mandatory. You can access 1, 2, 3 because you are getting by the dot. Third one is like map. So my map column name is DUD. So see here the difference. When you are giving in the square bracket index, it will be used as an array. When you are giving in the square bracket in the single code, you are giving key, you will get map. That's the difference. And DUD, you will say EPF. Okay. Now you will give the square bracket you will close, and from you will say the table is a tab level. Now you will see wherever the data is not there for EPF, it is coming null because this EPF is not here. EPF is not here, right? So this is not there, but the other data all are coming, right? Whatever city, state, pin code, and all array indexes all coming. So this is the way to get the data. Okay, so this is the second thing we done, the basically how to do the complex data type. Okay, is it clear so far? This one, this is a small concept. If you do practice, I'm taking time to make you understand, but I'm saying like when you do practice, you can do within 10 minutes, you can do this practice. Okay, so this is not like a very time consuming things. Okay, if you have the commands ready, you are not writing manually the command. Okay. Okay, so next thing is like a different types of file format data is there because we are dealing with Hive is like having different types of file format support is there, right? I already discussed, right? Avro file, ORC, Parquet, okay, and CSV, JSON, XML, all different types of file format data is supported. Okay, okay. Yeah, let's take a 5-minute break, 10-minute break. Okay, I will cover this file format and then I will cover I think 2 more things I will cover also. Actually, UDF I want to cover and different types of surveys. Okay, so these things we have to cover. Okay, so it will not cover completely, but we will keep it target for Hive and tomorrow Scoop, Hive, Scoop, and HBase. So I believe Hadoop part will be completed in this weekend. So we can start for the Spark. Okay. So Hadoop is just for knowledge. You see, it's just 20%, 10%. Okay. We cannot know in interviews. Maybe sometimes you are getting only 10%, 15% questions. Okay. Because majority 50 to 60% is a Spark with cloud. Okay. That is a majority percentage. Okay, but still we have to prepare because the background is Hadoop only because the base is Hadoop, right? If you are working on the large data analytics, you will use Hadoop file system. Okay. Okay, so let's connect in the 10-minute. Okay. Yeah, you guys able to hear me?
Yeah.
Okay. So first we talk about complex data type. Complex data type we have already seen. Okay, so different types of file format. Okay. So if we talk about the different file format data, so there is a Parquet, ORC, Avro. Okay, so these are the three common like file format is there. Okay, so first we understand like if these file format data are there, like how the data will be stored internally, how they are. So these are the faster to read or faster to write. Okay, so if I say the text file format data is there, so text file format data, the common data format, right, which is used, right, CSV file, JSON file, XML file. These are the human readable format. The human readable the format, right? This is called text file format data. That data is a text type. Okay. Even the CSV is also text file format, JSON also text format, and XML is a text format. But internal record format is a CSV. How the records are populated, that is a CSV type, JSON type, XML type. But the file format is the text format. Okay. Another one is like Parquet. Parquet is corner file format. Why it is called the corner? And this is the row oriented file format. The another thing we can say row oriented file format. The data is stored as a row by row oriented file format. So data is stored in files, the underlying storage data, right? Because table is a tabular representation. When we look at the data in the table, it will be coming as a table, like as a row and column. But underlying storage, the data is stored in file as row by row. Okay. And the corner file format, Parquet and ORC, these two are the corner file format. So corner file format are faster to read. Faster to read means you can read data faster. When you do select query, your data will be read faster because the data is stored in files as column oriented manner. So in the one column, the entire row data is there. So column oriented manner. Okay. So if I say I have a like ID, name, and city. So like this column oriented manner data is stored. So this is one column, second column is the ID value, name value, okay, city value, okay. This is the next record to the name. So instead of call row, the data is stored in the column oriented manner. And why it is faster? Suppose you are going to say, I want to get the ID 1. So it will be reading data only one single column, the entire data for that particular ID. Okay. So, so if I say it's faster to read, okay, but not writing data faster. Writing data is not faster, but reading data is faster. Okay. But in case of row oriented, it is faster to write. Faster to write. Okay. But if I say read is not faster, read is not faster. And another one is row oriented is Avro. Avro is very popular file format in Hadoop, right? Hive is supporting, Spark is supporting. So Avro is also row oriented file format. Okay, means faster to write. And advantage of Avro is it's having schema evaluation. What is the schema evaluation? Because your schema is keep changing, right? Schema evaluation. Suppose you have today is a 4 columns in the file, okay, in a file, okay, and tomorrow you add one more column, add one more column, okay. So your existing schema should not be impacted, right? Because the values for this new column will be null, right? For the existing data, for existing records. But for the new data, you will be inserting the new data values, okay? So add one more column. So or remove any column, add one more column or remove any column, Your data will not be impacted. Data will not be impacted. Okay, so this kind of thing is called schema evaluation, and Avro is a very good fit for this. Avro is good file format where the schema is keep changing frequently. Avro is a good file format for the schema is keep changing. Okay, so we go for the Avro. Okay, so how to use this file format in the actual tables? So whenever you see that, whenever we are using, we have to use for CSV, JSON, XML, like these are called SARDs. Okay, so whenever we are reading a specific type of file record format, like say CSV, so there is a CSV SARD. So CSV SARD is a serialization, deserialization. So, but CSV we are already reading, right, comma delimited. But here CSV means like some double quote values are there. Suppose you say your values are in the double quote, comma separated, or sometimes you have like comma within double quote, right? Suppose you have a first name, last name. Okay, so you have a values like this, or you have some values like you say you are using slash, double slash you are using. Okay, some path you are saving in your column. Okay, XYG. So this kind of data where the comma delimited data, this is called open CSV survey. Open CSV survey, you want to read the data as it is double quote. Okay, so open CSV survey is there. When you have a JSON data we all know, right? The key colon value. Suppose I say ID is 1 colon, name is some XYG, and then I say age is number. Okay, so some number value like this. So this is the one record. So I say second record I'm going to create similar way. So this kind of data is called JSON data. So JSON data, like we are reading the JSON data, we are reading through JSON survey. So there is a JSON survey. So why it is called survey? Survey is a specific type of class is there, and that class is helping out to parse the JSON file. Okay, because in the Java, if you are going to write code for JSON, so you will be using JSON libraries. If you want to read some CSV file, there is a CSV library. XML for XML survey is there. So Hive has provided, just you use in your create table syntax, you just provide this survey class. And after that, you load the data, your data will be automatically parsed. Okay, so XML survey, you know already, right? There the XML tags are there. So employee tag is there, ID tag is there. Okay, so there's the ID tag. And so this kind of data is called XML data. And this XML data, you will be reading use XML survey. Okay, I will cover all this survey. It's just very simple, like you will be using a create table syntax, and then you will load data and it will be putting the data in the table. Okay, and another one more survey is regex survey. Suppose you have a log files data, some fixed delimited files. So you know, right, first is the user ID is there. Then you have some HTTP request is there, right? And you have status code is there. So some 6-7 columns are there. 7 columns are there, and size is there, right? So okay, you want to read the data, but there is no delimited character. So that kind of data called fixed width file. Okay, we use a regex array. So regex array is regular expression. So regular expressions array we use to read this kind of file format data. Okay, so these are the different categories. And Parquet, Avro, these are the 3 surveys. These also surveys, Parquet, Avro, and ORC. For this type of survey, we are not using any class. Just we are making it our create table syntax stored as Parquet, stored as Avro, stored as ORC. If you choose any one of these, it will become that particular file. So basically this Parquet, Avro, ORC, these are the compressed file format. Compressed file format means like it's not a text file format. So compressed file format is taking a less size. So if the compression level, if I talk about, so ORC has higher compression ORC is higher compression. Compression means like if I have some 500 MB file in text file format, ORC will make it like 200 MB. Parquet will make it 300 MB. Avro will make it 400 MB. So it's like compression is becoming like higher in ORC. Next is in the little less in the Parquet. Parquet has lesser than ORC. Okay, and if I say Avro is lesser than the Parquet. Okay, so this is the but other file format like CSV, JSON, there is no compression because these are the text file format. So text file format, there is no compression. So compression is there. Even regex also no compression. Only Parquet, Avro, ORC. So Avro, Parquet, ORC, they have attached schema and attach the schema with this file format as well as like your compression is there. So ORC has compression, Parquet has compression, but ORC compression is higher than Parquet and Avro. Okay, so we need to understand the difference clearly, and we should know how to use these file format, how to use in Hive to load the data of these different file format, because we are not always working normal like a CSV, JSON, XML file. Sometimes we are getting the data from the vendors, Parquet type file format, Avro type, or what. Okay, so we should know about these file format, how these are beneficial, how these sometimes we are writing our data as a Parquet, Avro, ORC. So if you create your table stored as Parquet, Avro, ORC, you can make it whatever data will load in this file, this table will make it automatically Parquet, Avro, ORC type. Okay. And one more thing is in these type of file format, you cannot directly load data local command. You cannot write data. So you have to use some source table. So source table, you write the data first. Okay. From your files, load the data into from your files, load into source table, load into source table, and from source table load into insert into target command, insert into target table, load into the Parquet, Avro, ORC table, target table of Parquet, Avro, ORC. So this is the way of loading data, because these tables cannot directly load the data. We cannot directly load the data. Okay. Okay, let's see the example.
Sir, what is Surday?
Surday is serialization, deserialization. So it is like basically different types of file format. I want to write into Hive table. We use Surday. So Surday term is like basically, serialization, deserialization is a very common terms in the different programming languages, right? When we are converting data into byte array and transferring over the network. And the other hand, once the data is transferred, then data will be converted back into the primitive data. So this Surday is basically the same like other programming languages, but here we are not doing any programmatic approach. Just we are creating our table of different Surday type, like JSON Surday, CSV Surday, XML Surday, and then we are reading data, and then if you see here, I have mentioned here like this is like a JSON Surday. So I'm creating a Surday type. This is stored as a text file, but I'm using here JSON Surday. I'm telling here the JSON Surday class. So this class is making my data. This class is making my data is a Surday type. Okay, so there could be a different types of Surday. So we have to choose the appropriate Surday, right? Which Surday is used. Okay, if my data, my source data is a JSON file, so definitely I will go JSON Surday. If my data is a CSV double quote data, I will go open CSV. If my data is a XML, I will go for that. Okay. And if my log files data is there, I will go regex Surday. If my data, I want to like some Parquet file, so I will write the Parquet data, right, in the Parquet survey. Okay, so this is kind of like serialization, deserialization we use in Hive to parse the data from the different file format, because underlying Hive is storing different file format. But when you do the select query to the table, all will be showing you the data as a tabular. So Hive table will be showing the data tabular only. Okay, is it clear, this one?
Yes, sir.
Okay. So, so first I'm just going to show how to create a Parquet file. Okay, Parquet table. So simply Parquet table, just you make it stored as Parquet. It is becoming now Parquet. But how to load data? So I have created one source table, and this source table I have a data, and I'm loading into the source table. And from this source table, I'm using insert into table command. So I will show you when the data is loaded in this table, the underlying data is stored, the file which will be stored in this table, it will become Parquet, because I'm using here stored as Parquet type. Okay, same thing is applicable to the ORC, same thing will applicable to the Avro. Okay, because when I say stored as ORC, my data will become ORC. So only just compression is higher and lower, right? But underlying table structure and like if I say the schema and then data in the table, it will be same. There is no change if I'm loading the same file. Okay, but only difference is if you see the size of the file of Parquet, it will be little more than the ORC. ORC is higher compression. Okay, and same thing if you apply for Avro. Avro is having the more, right, less compression, right? Okay, so Avro is a very, very least compression. Okay, but Avro is having the other benefit, right? The schema evaluation support is there. Okay, so let me create a one table, source table, and this data. This is a source data. Some test. And I'm creating a source table and loading into data. Okay, so load data local. Hive test 3. And my file is only test into. This is normal, just simply I'm going to into table test underscore source. Okay, so now simply data came. Now I'm creating a one Parquet file of the same structure. Just only difference is I'm creating here the Parquet stored as Parquet. Okay, so now I want to load the data into this Parquet. What is my source table? Test underscore source and test survey Parquet 2. So test survey Parquet 2 and test underscore source. So now I'm going to write the data. So when you query the table, you will get the same tabular data. Okay. But when you are checking the data file, it will be Parquet. Okay. So Parquet file, like sometimes extension is there, like .parkut. Okay. Because it's a Parquet file, because it's a compressed file. You can not see it. Okay. Now if I do query stuff. So this is my table. Okay, so already this table was loaded, so that's the reason double data is coming, but this data is loaded. But if you want to see the original Hadoop FS minus ls. So user Hive warehouse / testing.db. And then my table folder. So if I want to check my file is there, so one file is created. This file I have not created. When the data is loaded, this is the Parquet file is created. So when I see Hadoop fs get command, so it's a compressed file. So you can read somewhat data, but not understand completely. Okay, because it is its own schema and everything is there in this file. So this is the file content starting like this. Okay, so basically this is a Parquet. Same thing like you can do for ORC, same thing you can do for app. Okay, so I will do one thing. Tomorrow I will show you the other file format, SARDES and UDF. And mostly like if I say the Hive, the 50% part is completed mostly. So then some other integrations also there, like Hive with the scoop integration. So that will come when I will teach the scoop. Okay. Okay, so I have a one session. Okay, so I will connect tomorrow, same time, 10 o'clock. Okay. Yeah. Okay. Thanks, everyone. Thank you.
Thank you.
Share the recording. Okay. Yeah. Okay. Thank you. Bye.